Raz. Hello.
Wondering.
Okay. Thank you very much for giving me the opportunity to speak here on this stage. I would like to start with a simple question. Who has heard something about insects, no matter what it was? Please raise your hand. Wow. Good, great. That's more than I expected. Did you know that we can use insect protein in both animal and human nutrition? Insects represent the most populous dynasty on Earth. Scientists estimate they make up an incredible 80% of all known animal species. To put it into perspective, for every single human on this planet, there are more than 1 billion insects. My name is Kristína Kolbaská, and I am a PhD student at Slovak University of Agriculture in Nitra, specifically at Institute of Nutrition and Genomics. On this slide, you can see two types of animals which I work with. Know me. I work with African elephants at zoo, and of course, the insects are hidden down in the grass. When I started work with insects, people often ask me, why insects? You spend much time studying African elephants, and now you are switching to bugs? That makes no sense. And honestly, looking at this photo, I completely understand why they thought that. But I didn't know why I made this big change in my life, and I just felt it was a right shift. Luckily, thanks to the Erasmus program and our collaboration with Czech University of Life Sciences in Prague, I spent 4 months in their insectarium and laboratory. Well, and what exactly did I do there? We feeding insects to insects. Specifically, we replaced a plant protein source from soybean meal with an animal protein source prepared from insects called black soldier fly larvae. And we tested how this affects to growth, feed intake, and production of mealworms and the crickets. And yes, we simply know, in the context, my research focuses on the untapped insect potential of animal nutrition, and we simply wanted to push of the science something truly new and innovative. On this slide, you can see now there are up 8 billion people on Earth, and by the year 2050, this number will reach 10 billion people. And here lies the problem, because our traditional production, plant and animal protein sources is already pushed to its limits. And this system cannot feed our world. Today, I want to share with you 3 global challenges that make my research ever more important. The first challenge is the legislative barrier. The European Union has some of the strictest food and feed safety in the world, but these laws are holding us back because these laws were built for traditional plant and protein animal sources. And they pushed to 𝗡𝗄𝗄 insect protein production and trying to 𝗡𝗄𝗄 them to insect protein production is like trying to install a latest smartphone app into 80s computer. It just doesn't work because because the implementation of specific rules may still differ slightly across the European countries. The second challenge is Europe's dependency on imported proteins for animal feed to feed livestock and fish and farms across Europe. You can see the European Union imports every single year 30 million tons of soya from Brazil, Argentina, and United States. So this is equivalent for 50 million full-grown cows every year, or 137 cows every day. And our fish production is just 10% of global market. So, if you want 1 ton of fish meal, you need catch 5 tons of wild fish. It's incredible amounts. Our third challenge is the environmental cost to traditional feed. One of the most reasons why researchers looking for the alternative to soya is the environmental impact. Large areas in natural ecosystem are being converted into fields, contributing to deforestation and biodiversity loss. So, soya cultivation is almost what amounts for land and water. If you have an idea, every single year we lose 3 million hectares of forest to soya fields, and that is equivalent to half the size of my country, Slovakia. And what is the main message behind all of this? As a global demand of protein continue grow, we urgently need sustainable alternative proteins such as insects, algae, or lupins. And right now, the insects are ultimate outsider in the European Union. So, how is my research processing? My research is still ongoing and focuses on evaluating feed for black soldier-fly larva meal as alternative to soybean meal. We tested 3 different diets. The first diet is a control group, which was fed standard broiler starter diet containing soybean meal. Starter diet for broiler is the absolute industry feed for insect farming. Second group is mixed group because contain 50% of BASF larva meal and 50% of soybean meal. And the third group was fed full BASF larva meal. So our results were very promising because at first our crickets needed a few days to adapt to animal protein sources. Looking at the details, the mixed group resulted the best growth and feed intake. It means they turned feed into biomass efficiently, and the full group with BASF diet had a higher percentage of crickets' adult life cycle. So I can told you, or I can say you, the mixed group has achieved the best results because the BASF diet perfectly balanced what soybean meal was missing. And now, or second, our preliminary results is breeding crickets is normally approximately 50 days, and mealworms 3 months. We but we added insect meal or animal protein to their feed. We managed the shorter life cycle for both species about 45 days. This is huge win in the insect production or industry. And I have some news with I share you. Thanks to my internship with Czech University of Life Sciences in Prague, my university has been invited to join an international collaboration research project. We will collaborate with our colleagues from Czech Republic, Hungary, France, Slovenia, and Serbia. And this project and our project will focus on nutritional strategies on both animal and human nutrition, and now we are discussing the research design. And we hope that this collaboration open new research, new door to research.